one is Newton's law of growth and decay. So, so generally, statement is very important. Then he will be always asking you to state Newton's law of cooling, Newton's law of growth or decay, like that. Based on that, he will be asking a simple problem. Okay. So, if you see the Newton's law of cooling, statement is something like this: the rate of change in the temperature of an object, you can say body or an object, is directly proportional to the difference between the temperature of that object and temperature in the air, that is medium. So when you change this sentence statement into mathematical form, the rate of change in temperature of the body or object with respect to time, that is d, capital T indicates for the temperature of the object, small t indicates for the time. So dt by dt is directly proportional to difference between the temperature of the object, that is capital T, and the temperature in medium, that is air, that is Tm. See here, in generally in textbooks, the notations may be different. Okay, so in textbooks, he will be specifying them as theta and theta naught. Theta indicates for the temperature, theta naught indicates for the temperature in the air. So but concept is same. So here I'm just noting, denoting with capital T and small t, tm. Okay, so when you change that proportionality into equal to, so we'll be having as proportionality constant as k. Basically we'll be going with the k here, with minus k here, because as the time is increases, temperature decreases, so therefore we'll be going with minus k. If suppose as time increases, temperature is also increasing, we'll be going with plus k. Okay, so depending upon the situation, but here in this situation, as time increases, temperature decreases, so we'll be considering that proportionality constant as minus k. So it will be dt by dt is equal to minus k into t minus tm. So if you solve this differential equation with respect to independent variable small t time and dependent variable capital T temperature, okay, so by solving this differential equation, by variable separable method, you will get an equation like this. Already you know that one. T is equal to Tm plus C into e power minus kt. You need to remember this one. So in textbooks you may have the theta is equal to theta naught plus C into e power minus k into t. So just notations are changed here, that's all. So you need to remember this equation, otherwise you have to solve this one. So so questions will be always like this. If a hot body cools in air at a rate directly proportional to difference between the temperature of the body and that of surrounding medium. If the air temperature is maintained at 30 degrees and body cools from 80 to 60 degrees in 20 minutes, find the temperature of the body in 40 minutes. So here you will be always given two types. One is asking you to find the temperature of that body in some time. So the other one is the temperature of that body will be given and you will be asked to find the time. So these two type of questions, but procedure is always same. So whenever you are given a question based on this, always try to first to denote what you are representing, whether you are representing capital T or theta. So if it is, what is that one? T indicates for the temperature of that object, and Tm indicates for the temperature in the air. Like that, first you describe and you start. Okay, so if you see in this question, you are given that air temperature is maintained at 30 degrees. That means Tm, or you can say theta naught. So Tm, temperature in air, is given as 30 degrees. Okay, and you also given that change in the temperature of the body from 80 degrees to 60 degrees in 20 minutes. That means when time is initially 0, temperature of that object was 80 degrees. After the time changes to 20 minutes, that means as time is increasing to 20 minutes, temperature of that object is decreased to 60. Means here time is increasing, temperature of that object is decreasing. So we'll go for this minus k as proportionality constant as minus k. So clearly this is related to Newton's law of cooling, because object temperature is cooling down, therefore we'll go for Newton's law of cooling. Okay, so by Newton's law of cooling, so rate of change in the temperature of the object with respect to time is directly proportional to difference between the temperature in the object and in the temperature air. Okay, so if you have time, you can simplify this one, or else you can directly write down this equation as T is equal to Tm plus E into e power minus kt. Okay, so what we are asked here, we are asked to find the temperature of the object, temperature of the object in that 40 minutes. Okay, so when time is 40 minutes, what is the temperature? So we have that temperature in air is 30 degrees plus C into E. C we don't know, e power minus k we don't know, into T we are given that 40. So to get this T value, we require this C value and this k value. So first we will find the C value, k value. Very simple. Always you will get this C value from the initial condition. Using that one and second condition, you will get the k value. So by the initial condition, when time is 0, temperature given as 80 degrees. So when you substitute in this equation, so when T is equal to 0, okay, and temperature is 80. So capital T is 80, temperature in air is given as 30, plus we see we don't know, e power minus k into time is 0. So as the power is 0, this will becomes 1. So this will be C is equal to 80 minus 30, that will be 50. So always you will get that C value from the initial condition. So using this one and second condition, you can get the K value also. So second condition we have that when time is 20 minutes, temperature of that object changed to 60 degrees. So here T is equal to 60, air temperature is 30 plus C into e power minus k into time is 20 minutes. So we have C value also here, substitute over here and simplify like this, so that you will get this as so when you are using your calculator, so this is as this is the e power minus 20k is equal to 30 by 50. So it changes to minus 20k is equal to log of 30 by 50, that is 3 by 5. But log with base c, so therefore you should use the in the calculator ln button but not log button. Okay, so use ln of, that means indicates for log with base c. If you go for log button, it will goes for log with base 10. So therefore use ln button in the calculator, so that you will get that k value. Once you have this k value, c value, substitute in your equation, that is this is your answer. In this we require c and k value. So using first condition, you got c value as 50, and second condition k value we have as minus 0.05108. So substitute there, you will get the answer. Is this clear? Is it clear now? Very simple and easiest problems which you are not supposed to neglect. So very, very simple and very important problems. Okay, so this is Newton's law of cooling problem. Any situation, okay, so there will be change in this situation. That means instead of a body, he may give some chalk piece, he may give some item whose temperature is decreasing or as time is increasing. Whenever if you have a question where the temperature of an object is decreasing as time is increasing, you should always go for Newton's law of cooling. So that formula will be T is equal to temperature in the medium plus C into e power minus k into T. Use that one and given conditions use, so that initial condition you will, with the initial condition you will get C value, and the second condition and C value you will get the K value. Substitute that, so that you will get the answer. So this is about Newton's law of cooling. Now let us see that Newton's law of growth and decay. Okay, so here both are same. So statements are very important. Newton's law of growth and decay. So it is nothing but the rate of change in the amount. There it is indicating for temperature. Here it is amount of a substance at a time t is directly proportional to the amount present in it. So that means if you denote that amount of a substance as x, so the rate of change, that is dx by dt, the rate of change in the amount of the substance x with respect to time t is directly proportional to the amount present in it. So here growth and decay. So growth means you will be having proportionality constant as plus k. Dk means you will be having proportionality constant as minus k. That means as time is increasing, the amount of the substance increases. Therefore, it is Newton's law of growth. As time is increasing, the amount of substance decreases. That is related to decay. So, for growth problem, you should consider proportionality constant as plus k. For dk, you should consider that as minus k. So, when you simplify this one by variable separable method, you will have that x is equal to c into e power kt. Okay. So similarly, Newton's law of decay. So that means proportionality constant you should consider as minus k, minus k. There you should take it as plus k and it is minus k. It depends upon you to, by seeing the question, you should decide whether it is decay problem or growth problem. Clear? So if it is as time increases, the amount of the substance decreases, then you should go for decay, considering as minus k. So as time increases, amount is increasing, you should go for growth problem, that is plus k. So both the equations are same with a small difference. Here it is x is equal to c into e power plus kt. So here you will be having x is equal to c into e power minus kt. Okay, clear? So very important. So if you see this one, based on this, you have one question in the previous question paper. That is, I'll just show you 1 minute. So if you see this one in that last year question paper, are you able to see this one? So if 30% of a radioactive substance disappears, yes, I said I will send these PDFs and also this question paper as well as this important questions. So I'll forward to this forward both first unit as well as second unit today. Is that okay? Today I'll forward both first unit as well as second unit, these PDFs as well as those important questions and this question paper also. Okay. So if you see this last year question paper, so in this first question was related to that linear differential equation. Okay. And the second is related to your application. So here if you see 30% of a radioactive substance disappears in 10 days. A substance is there which is decreasing in 10 days. That means as time is increasing, amount is decreasing. That means it indicates for the Newton's law of decay, not the growth problem. So question is how long will it take for 90% is to disappear? So he is asking you what is the time. Okay, so as 90% decreases, what is the time he is asking? So just we'll see this one. Now, so see here, so since the amount is decreasing as time is increasing, so therefore we'll apply Newton's law of decay. So we should denote x. So it is up to you, x you want to go for x, any variable you can go. So please always denote with some letter. So let x denotes the amount of the substance. By the Newton's law of growth of decay, the rate of change in the amount of the substance with respect to time, okay, is directly proportional to the amount present in it. When you simplify, because as it is time increases, amount is decreasing, you should go for proportionality constant as minus k, that is decay problem. So when you simplify this one, you will have directly you can write like this, x is equal to c into e power minus kt. So what we are given there, initial when time is 0, that amount of the substance we don't know exactly what it is there. So let us consider that as x only. When time is 0, the amount of the substance is x only. So when you substitute here, so x is equal to c into e power minus k t. T is 0. When you substitute 0 here, power 0 is 1. So c is equal to x. So with this c is equal to x you will have. But second condition what he is saying, in 10 days. Okay. So in 10 days, 30% of that substance is decreased. That means in 10 days, how much it remains? 70 percentage of that actual amount. So therefore, when time is 10 days, X, the amount of the substance will be 70 percentage of that actual amount. So therefore, it is X is equal to zero point 0.7 into X. Okay. So use this condition so that you will get the K value. Okay. when t is equal to when t is equal to 10, the amount of the substance is remained is 70 percentage of that actual amount, that is zero point 0.7 into x is equal to c, where c we have as x into e power minus k into t we are having as 10. So substitute here so that simplify, you will get that k value as 0.03567. Okay, so as it is, when you apply log with base e, that is ln button you should use, so it will be this one. So k value you are having. So what we are asked, what is the time when the amount of that substance is decreased to 90 percentage? That means remaining percent is 10%. So how many, after how many days you will be remained with only 10 percentage of that amount he is asking. So if x is equal to 10 percentage of that actual amount, that is zero point 0.1 into x, what is the time you were asked? So here, so zero point 0.1 into x is equal to c, that is x into e power minus k t. T we don't know, we need to find k into t as it is. So this will be zero point 0.1 is equal to e power minus k we have as this value. As we require this t value, we should write remove this exponential, that is log with base e of zero point 0.1 is equal to this one. So that simplifying this one, t we will have as some 64 days. Is this clear now? Is it clear? Okay. So this is about the this is about the applications of this one. So with this, that first part of that first unit is over. So second part is ordinary differential equations of first order and higher degree. So here we will be having the differential equations of first order only, but degree is not of 1. It may be 2, 3 like that. So in such cases, you will be having three types solvable for p, y and x. Okay. So generally for solving that p, what you have to do means you need to express the given differential equation. Here p indicates for dy by dx. P indicates for dy by dx. So that is dy by dx whole power n. That is power is n, degree is n. Okay. So like that, this is a differential equation of first order of higher degree as n. So whenever you have a differential equation like this, to solve for p, what you have to do means you have to express that into factors. So try to express this equation in the form of factors and equate to 0, so that simplifying that one you will get some solution like this. Constitute of all these solutions will be the general solution. Like this, if you see here, a simple one. So you are given that x square is equal to 1 plus p square. That means here p indicates for dy by dx whole square. That means first order, second degree equation. First order, second degree. So to solve that one, just here directly we can have here p is equal to, so that we can directly solve by using that variable separable method. Okay. So if you see this one, if you see the second example, so it is x square p square plus 3xy p plus 2y square is equal to 0. So here it is in the form of some quadratic equation. So if you treat this as x, that is a x square plus b x plus c is equal to 0. So it is in the form of a quadratic equation. You can solve that one, that is minus b plus or minus under root b square minus 4ac by 2a x is equal to. So like that also you can solve, or you can express in this way. It is up to you. Okay. Basically, if you can find the factors like this, it is okay. Otherwise, like this, if you see here in this example, so this is this equation where it is in the form of a x square plus b x plus c format. So in place of x you have p, that's all. Okay, so as it is a quadratic equation, ax square plus bx plus c equal to 0. So the factors how we used to find, so x is equal to minus b plus or minus under root b square minus 4ac by 2a. Like this also you can find. Once you have these factors, okay, once you have factors like this, that is, solve them by variable separable method. So by variable separable method, you have to solve. So any equation if you are given, okay, so you need to just find the factors of that equation. Once you have the factors of that equation equal to 0 and solve them by variable separable method. So here dy by dx is equal to 2y by x. Okay. So by variable separable method, this will be 1 by x into dx, like that 1 by y into dy. Right. So this will be 1 by y dy minus, if you write this side, minus 2 by 1 by x into dx equal to 0. By variable separable method, integrate them with respect to y and x, you will get the answer. Like this, for this factor you have to do. Once you have both together, the is nothing but your solution. Okay, so like this you have to do for this solvable for p problems, like that solvable for y and x problems. That means if then given equation which is not able to solve like previous method, you can express that in the form of as y is equal to terms right side as in the form of x. Please share this PPT. Yes, I will share. I will share this PPT as well as questions after this class. Don't worry. So if it is not solvable by the previous case, you can express the given equation in the form of y is equal to in terms of x and p, or x is equal to in terms of y and p. So once you can express like this, so here you should differentiate with respect to x, here you should differentiate with respect to y, so that you will have dy by dx is equal to, when you differentiate, you have some function which is in terms of xp and dp by dx. So this side dx by dy, similarly like that. Okay, so basically you know that dy by dx is nothing but p. So then dx by dy will be what? 1 by p. Okay, so it will be dx by dy is nothing but 1 by p you will have. Okay, so if you can express in this format or in this format, so you have to differentiate here with respect to x, here with respect to y, and solve this one into, that means try to express them into factors form. So once you have that factors, try to consider the factor which contains the dp by dx or dp by dy terms. So consider those things and solve them, then you will get the solution like this. So just see here one example. So if you see here, y is equal to 2px minus xp square. P indicates for dy by dx, that is a first order of degree 2. So you should solve in this second case. Okay. So given equation, clearly it is in the form of y is equal to in terms of x and p. Okay. So therefore differentiate with respect to, sir, how to find whether the given equation is in the form of x or y. So that is what I was telling you people. So it is, you are supposed to practice. So unless until you won't practice, you will not get this one. So some problems while directly expressing in terms of y is equal to or x equal to, directly you will have. So some problems like this, when he has given, by seeing this one, you should be able to identify y is equal to a function which is in terms of x and p. So directly you will have something like this. Or when you are given an equation totally like this, minus 2px plus xp square equal to 0. So try to express whether you are able to express in the form of y is equal to or x equal to, you should try. Unless until we cannot get over here, because there is no method where you can directly identify whether it is in the form of y is equal to or x equal to. We are supposed to try to express into in that format. Okay, by using by giving, by seeing that question, you should be able to try. There is no other option, because direct methods are not there for us to identify y is equal to f of x comma p or x equal to f of y comma p. Just from the given question, you should try whether you can express y is equal to or x equal to. If you can express, then you can solve like that. Suppose if you are unable to write this equation in y is equal to f of x comma p, then try to express x is equal to f of y comma p. Compulsory you will have in any one form. Sir, can we do through by roots? For which problem you are saying? So here, uh, so for this problem, so roots are also you can find out as it is directly there in the form of suppose if you write this one as xp square minus 2px minus y equal to 0. So it is in the form of a quadratic equation as I was telling you. So you can also try in that way. That is a x square minus 2p minus 2xp minus y equal to 0. So you can also try in that way. That means solvable for p also you can have. Very good. So so you can also try. That is what I'm saying. When you are given a question, first always try to see the possibilities. First possibility, that means solvable for p or not. That means whether you can able to find its factors in the form of dp by dx or not. So once you can express, then it is you can solve for p. Suppose if you are unable to express into the form of factors, then you should try for this second case, that is solvable for y. That means you should express in the form of y is equal to f of x comma p. Even suppose if you are unable to express in the form of y is equal to f of x comma p format, then you should try for x is equal to f of y comma p form. So this problem you can solve for p also, solvable for p, because this is in the form of a x, that is ax square plus bx plus c format, where a is here x and b is here 2x and c is minus y. You can try in that way also, that is solvable for p. But now if you see this one, our question is directly is in this form, y is equal to f of x comma p. So we'll solve for y. Okay, that is differentiate with respect to x, so that what you will have dy by dx is equal to, so here p indicates for dy by dx and x indicates for a function. That means both are uv format, both the functions are there, you should differentiate uv rule. So first with respect to x, that is 2p into x plus 2x into this p, that is dp by dx, minus again this one is in the form of this is a dy by dx whole square, and this is a function. So again you should apply here uv rule. That is with respect to x it is p square, and x into this derivative is 2p into again dp by dx, right? So and try to express in the form of factors like this. Okay, so just go through this one. Dp by dx is nothing but p only. So this 2p minus p and this minus p square, and here dp by dx is there, dp by dx is there, x is there. When you consider as common, it will be 1 minus, here p will have this minus p square is there, and this 2p is there, and this p dy by dx is nothing but p. This side if I write equal to 0. So when you simplify, you have that p minus p square like this. So try to express in the form of factors like this. So once you express in the form of the factors where you have a factor with dp by dx, such factor should be considered and the other factor should be neglected over here. Okay, so consider the factor where you have dp by dx terms and neglect the factor which is not included there. So neglect this term and consider this one and solve for the p. So once you solve that one, that is p plus 2x dp by dx equal to 0. So p is equal to minus 2x dp by dx. Like that by variable separable method, if you solve that one, you will have some value like this, where p square is equal to c by x. Once you have this p value, substitute in your question, so that it will changes in terms of x and c formats. Okay, so 2px minus xp square, where p is equal to square root of cx and this one. So therefore, from the given equation, this is this equation where you have dy by dx. So this derivative has been removed, that p has been removed by substituting that p value as c by x over here, p square value. Is this clear? Is this clear? So similarly, you should solve for X format. So like this. Hmm. So solvable for X. So this is that equation. Once again, if you see here, this is ax square plus bx plus c format. That means you can try this one by solvable for p also. Okay, or you can express in the form, when you write y is equal to, it will be xp minus p square. Means this can be solved by solvable for y, second case. Also, if you see this side, xp is equal to like this, you can also express x is equal to. That means this problem can be solved in the three cases. First case, you can solve for p. Second case, that is y is equal to f of x comma p. And third case, x is equal to f of y comma p. That means a problem can be solved in three ways. Okay, so procedure is same. So here, if you express y is equal to like this, differentiate with respect to x here. So if you express x is equal to f of p comma y, you should differentiate with respect to y. So after differentiating, you should be able to write in the form of factors, and you should consider the factor which have dp by dx terms. So here you should consider the factor dp by dy term. That's all. So a factor which contains dp by dy terms you should consider over here, and here factor which contains dp by dx, that factor should be considered, and solve for p. You will get that p value, substitute in the given equation. So anyway you can solve. Is this clear? Okay, solvable for p. So this is the first unit. So first unit, once again I'm saying, two parts are there. First part, in the first part, please concentrate more on applications, that is Newton's law of cooling, decay, growth problems, and linear and Bernoulli problems. Okay, so in general you will be given those problems only, from that only. And second part, that means the higher degree problems of first order, solvable for p or y. So in generally, we cannot predict which one we will be having. So therefore, you should thorough with the three cases. Only thing is, by seeing the question, you should always identify whether you can solve for p. If it is not possible, then you should be able to express y is equal to f of x comma p, and differentiate with respect to x, convert into in the form of factors, consider the factor which is having dp by dx, and solve for p by variable separable method. So if you are unable to express in the form of y is equal to, then you should try for x is equal to f of y comma p, differentiate with respect to y, and try to express in the form of factors, such that the factor which contains dp by dy should be considered, and solve for variable separable method, so that you will get p value. Substitute that p value in the given equation. Okay, this is about the first unit. So I'll forward these ppts, as well as the previous year question paper, as well as those important questions. Now just look at for the second unit. So if you see that second unit, so second unit is related to ordinary differential equations of higher order. So that means order is 2 or 3 or 4. So here in this, you are given some different methods are there to solve this higher order differential equations. That means when in a higher order differential equation, which is in the form of dy by dx whole power nth order, whole power 1, like that, n minus 1th order, like that, so on, where p1 p2 are the constants. Right side is a function which is in terms of independent variable called as x. Q of x will be there. So that equation should be expressed in the form of f of d into y is equal to q of x. You should replace the dy by dx with capital D, d square y by dx square with capital D square, d cube by dy x cube as d cube, like that, so on. So always we should express that given equation in the form of f of d into y is equal to q of x. If that q of x is equal to 0, we'll say homogeneous linear differential equation whose solution is complementary function. If that is not equal to 0, that is called non-homogeneous linear differential equation whose solution is complementary function plus particular integral. So we are given some methods to find the particular integrals over here when since q of x is particularly in the form of exponential form, sine or cosine form, e power a e power mx into v of x form or polynomial form, like that. When q of x is given in specific forms, you are given some specific methods, or you are otherwise you will supposed to solve by using general method. First, how to determine this particular complementary function. So complementary function is obtained by solving its auxiliary equation. Auxiliary equation is nothing but f of m equal to 0. Whatever you have that f of d, replace that d with m and equal to 0. That will be called as auxiliary equation. Okay, so solve that one, find the roots of that equation. So depending upon the roots, you will be writing the complementary functions. That means when the roots are real values and different, the complementary function will be given as c1 into e power first root x plus c2 into e power second root x. If they are real and same, when the roots are real values and repeated, it will be given as c1 plus c2x e power alpha x. Suppose three roots are there which are same, you will be having plus c2 c3 x square e power alpha x, like that, so on. When the roots are complex and distinct, so it will be given that is complex alpha plus I beta format. So when they are distinct complex values, it is given by c1 cos beta x plus c2 sin beta x into e power alpha x, like that. When they are same, when the roots are distinct same as well as complex same as like what you have written, you should write that is c1 plus c2x cos beta x plus c3 plus c4x sin beta x into alpha power x. Okay. So here what you need to practice is, in this unit always try to practice the problems which are in the form of q of x in the form of e power mx into v of. In generally, you will be always asked the combination of problems. That means when q of x is something in the form of e power mx, how to do, you know. So when it is in the form of sine or cosine, you know how to do. When it is in the form of polynomial, you know how to do. When it is in the form of e power mx into v of x and x power n into v of x. So whenever you are having the problems in the format of the combinations, such type of problems you should always practice. Like if you see this one, dq plus 4d into y is equal to sine 2x plus e power minus x. That means here q of x is in the form of e power mx first type, and this is sin mx, that is second type. So both the types are involved here. So these combination type of problems are very important. You should practice these type of questions. So here clearly right side quantity is not equal to 0, so therefore it is non-homogeneous linear differential equation whose solution is complementary function plus particular integral. So to find that complementary function, you should solve its auxiliary equation f of m equal to 0, where f of d is dq plus 4d. So f of m is mq plus 4m equal to 0, such that the roots are 0 and complex and distinct, that is 0 plus or minus 2i. So one root is real, so that c1 e power first root x plus the remaining two roots are complex and distinct. So therefore you will have C2 cos 2x plus C3 sin 2x into e power alpha is here 0. So this is that complementary function. To find that particular integral, which is nothing but q of x by f of d. So split it this one, it is this one. So now here sin 2x is there, that is of type 2 question, and e power minus x is there, that is of type 1 e power mx form. So you know the procedure. When it is in the form of e power mx, you should substitute d with that a. So m, that is minus 1. So you know that when it is sin mx is there, you should substitute the d square with minus m square in that f of d. So when you substitute d square term with minus m square, that is minus 4 in this one. So what will you have here? As this d square term is not there, we'll consider d outside so that you have d square. In this d square, you should substitute with minus m square, that is minus 4. Okay, and here in this, you should substitute d with m. So this one. So whenever first type, if f of m is not equal to 0, that will be this equation. Whenever it is equal to 0, you will be writing x into e power mx by f dash of m. So you know all these procedures. Okay, you need to just practice them, and please always try to practice the problems which are in the form of combinations like this. So sine and e power a minus x is there. So you should always concentrate more on such type of problems. So this is the exponent polynomial, you know. So when you are given in the form of polynomial, you should express into standard binomial form, that is 1 plus or minus x whole power n format. That means to reduce this into standard binomial form, you should consider the least degree term of that d as common here. So here if you see x cube by f of d, so in the degree is 2, 1 and 0. So whatever the least degree term is there, you should always try to consider as outside. Okay, so that is 1 plus x of this format. So it is in the form of 1 plus x, where x is in this format. So like that. So suppose 1 is not there here, d square plus d is there, then take d as common, so that you will have 1 plus d, 1 plus d will be there. So like that you should express into standard binomial format. As time is not permitting for me, so I'm not going in depth. Just I want you people to just practice more problems with the combinations. So this is very important, these type of questions. And on this type 4 e power mx into v of x, these type of problems will be asked more times. Okay, so please concentrate more on this type e power mx into v of x. If you know how to solve for e power mx sine or polynomial form, this one is over. With one step extra, what you have to do, just substituting d with the d plus m in that f of d, and you should write this m power mx outside, and you should solve for this one. Depending upon v, you should follow the procedure. If this is e power mx is there, first type, you should follow that procedure. If it is sine or cosine, you should follow the second type procedure. If v of x is a polynomial, you should follow the third type procedure. Like that, you should try. But please try to practice the problems where all these type of questions are there. Now, if you see this one, so here first type, this is e power mx is first type, and this is the fourth type, that is e power mx into v of x format. This is also e power mx into v of x format. But here v, that means all number type you should apply. Stable. Okay, so please try to concentrate more on these type of problems. Okay, and in this unit, what you are supposed to do is, so in this unit, the next type is method of variation of problems are there. This is very important. Compulsory you will have a question based on this method of variation of parameters. Basically, it is used to solve the second order differential equations. Okay, generally second order differential equation will be what? It will be in the form of d square y by dx square plus a function in terms of x into dy by dx plus a function in terms of x into y is equal to some function in terms of x. So in generally, so where these coefficients may be constants, or they may be in the form of functions. In generally, we'll our syllabus we are having these as constants only. Okay, So this is the second order linear differential equation. D square y by dx square plus p is p1 dy by dx plus some q1 into y is equal to r is a function in terms of x independent variable. So here in this directly he will ask you to solve this equation by variable separable method. Then only you should use that procedure. Otherwise not. So if you see this question, d square y by d square plus p is given as 0 and q is given as 1, r is given as cosecant x, right? So its a solution is given by complementary function as c1 u of x plus c2 v of x and particular integral a into u of x plus b into v of x, where a and b are called the method of variation of parameters. A is given by minus integral v into r by u v dash minus u dash v dx. Like that, b is integral u into r by u v dash minus v u dash. Okay, so first as usual, how you are finding the complementary function, you need to find that one, that is solving its auxiliary equation. Here auxiliary equation is what? D square plus 1 into y is equal to q of x, that is f of d is d square plus 1. So f of m is m square plus 1 equal to 0. The roots are complex and distinct, so therefore complementary function is this one. So in this c1 into u of x plus c2 into v of x, that means this is u of x and this is v of x. From the complementary function only, you will be writing that u function and v function. U is cos x and v is sin x. As in the particular integral, we require a and b, where a and b are obtained by evaluating these integrals. So we require this denominator, just we are finding that one. uv dash minus u dash v is nothing but so 1. So to find that a minus integral v is given as sin x, r is given as cosecant, by u v dash minus v u dash we have as 1. So simplify this integral. So whatever you have that a value, so just like that b value you need to find. So particular integral is a into u of x plus b into v of x. A you have as minus x, u is cos x, and b we have as log of sin x, and v is sin x. Like this you will be. So please, I'm requesting in this unit you should concentrate more on this method of variation of parameters. Compulsory you'll have one problem based on this method of variation of parameters. Okay, never neglect these problems. Directly you will be given solve by method of variation of parameters. Then only you should follow this procedure. Otherwise you should follow this previous procedures. Like this is in the form of e power mx type 1 procedure you should apply. Okay, otherwise you should solve like this in this method of variation of parameters. And next one is this next one, that is Cauchy-Euler equations. So these type of problems are also very important for us. So please concentrate more on this one. Okay, so in generally they will be in the form of x square d square, like that xd, it will be in this format. So Cauchy-Euler form will be like this. So for that what you need to do, just you need to substitute x with e power z such that log x is equal to z. So nothing but you need to change this d in terms of theta. Okay, that means xd will be theta, x square d square will be theta into theta minus 1. So please remember these things. Xd will be theta, x square d square will be theta into theta minus 1. Like that, if you have one more term x cube d cube, that will be theta into theta minus 1 into theta minus 2. If it is x cube x power 4 d power 4, theta into theta minus 1 into theta minus 2 into theta minus 3. So just remember these things, apply there, so that total equation which is in the form of f of d changes in terms of f of theta like this, x square d square, that is theta into theta minus 1 minus 4 into xd, that is theta plus 6 into y is equal to right side x is there, where x we have assumed as e power z. That means e power z whole square is e power 2z. So the total equation will be in the form of f of theta into y is equal to q of z. There you will be having f of d into y is equal to q of x. So independent variable we were having x, here it is changed into z because we have changed that in terms of z. So capital D derivative, capital D denotes for with respect to x, and theta denotes for with respect to z. Okay, so this you will be having when you assume x is equal to e power z such that log x is equal to z. Okay, so please remember these points. You should assume x is equal to e power z. Okay, this point you need to remember, and you need to remember these things: x d as theta, x square d square as theta into theta minus 1. Substitute there in this given equation, so that change that equation in terms of f of theta into y is equal to q of z. Once you have in this format, you should follow those procedures, because right side if you see, it is in the form of e power mz. That is type 1 procedure you should apply to find particular integral. And complementary function, as usual, solving its auxiliary equation. Roots are here 2 and 3, real and distinct. So c1 e power 3z. One point you need to remember, as here independent variable is z, you should write in terms of c1 e power 3z, not x. So many of the students will make a mistake of writing x over here. So for this equation you are solving, here independent variable is z, so you should write in terms of z. Okay, particular integral is e power 2z by that f of theta. So simplify this one by using that. So here how will you do? By expressing into factorization you have to do, and you have to simplify that one. So these procedures you know already. And please, here in this unit, please concentrate more on the second unit, more on the method of variation of parameters, and this Euler, Cauchy-Euler problems and Legendre's problem. The same problem, how you have this Cauchy-Euler form, Legendre's is also the same. So here you will have x d square. There you will be having some a plus bx whole square, a plus bx into d, like that you will be having. So just practice more on these problems. In the second unit, try to concentrate more on this legendary Cauchy-Euler and method of variation of parameters problems. So these are very very important, because many times we are asked these questions only. So legendary is same that format only. In place of x power n, you will be having a plus bx. So like that. So there what you have assumed, x is equal to e power z. Here you should assume a plus b is equal to e power z. The same procedure you will be having. So there you have x cube d cube as theta into theta minus 1 and theta. So here ax plus bx, a plus bx whole cube will be nothing but b cube, like that you should write. There xd is theta. Here a plus bxd is nothing but b theta. B you need to write just. Okay. A there x square d square is theta into theta minus 1. Here b square into theta into theta. There x cube d cube is this one. So here a plus bx whole cube is nothing but just b cube. Only thing is, there you will be writing theta, here b theta. There you will be writing theta into theta minus, here that is b square into this one. So like that b cube, so on. Only thing is, you need to write this a plus bx as e power z there. That's all. This one, a plus bx as e power z. There you wrote x is equal to e power z. Here a plus bx as e power z. That's all. When you simplify like that, you will be having this problem. So very 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 important. You need to concentrate in second unit more on method of variation of parameters and Cauchy-Euler problems and this Legendre's problems. These three problems, please practice more. And in the first part, that is types e power mx, e power sin x, cosine x, x polynomial, e power mx, v of x, exponent. So in that, please try to concentrate more problems which is in the form of the combination. Q of x is in the form of both the first type, second type. Such type of problems to please concentrate. Okay, so I'll forward these ppts and those important questions today only, right? So this is about your second unit.